Okay, this is Geometry Topic 6, and we're going to be looking at a new skill, something you haven't learned yet, most likely, in your Algebra 1 class, and it's solving by using the quadratic formula. We're also going to talk about how to name geometric shapes. So we have a couple things we're looking at on this today. So first of all, for the exploration, we're looking at this function, and you might notice there is an x squared. And because squared is the highest power, what I know about this is that this is a parabola. This is going to be a U-shaped graph. And these can either open up or down. And the way that this one opens, because the leading coefficient, the value of A is positive, this one's going to open upwards. Looks something like that. So the question for this was, can the x-intercepts for this function be found by factoring? Well, let's just try it. If I'm looking for x squared plus 3x minus 7, I'm going to try to factor this. So I'm going to take the x squared factors terms and split them up into factors of x and x. I'm also going to consider the factors of that last term, 7. It's really a negative 7, but I actually am just, for the moment, only going to worry about the 7. The only factors of 7 are 1 and 7. But I'm looking for factors that would combine through addition or subtraction to this middle term. And there is no way for 1 and 7 to add up to 3 or to subtract to 3. So this one cannot be solved by factoring. By square rooting. Square rooting is when you set the function equal to 0 and you try to isolate x. Here's a problem here. There's two different terms that have x's, and one of these has an x squared and one has an x. So there are no like terms, and I cannot combine unlike terms, which means there's no way for me to isolate x because I can't combine terms that aren't alike. And so if there's no way to isolate x, I cannot solve for x this way either. So factoring did not work. Solving by square rooting didn't work. So we're going to look at a different way. Now this picture actually shows what f of x looks like if you graphed it. Like if we used a table of values and we picked some numbers for x and we found out what those corresponding outputs were for y, and we plotted points, we would get this picture right here. And this says estimate the value of the x-intercepts. So you might remember, if we consider where the x-axis is, the x-intercepts are those locations where we actually cross the x-axis. It's a little hard to tell exactly where they are. It says estimate the value of the x-intercepts. It looks like this x-intercept on the right is somewhere in between 1 and 2. I'm going to say, I don't know, maybe 1.5. You might have said 1.4 or 1.3 or 1.6. That's okay. We're estimating. For the x-intercept on the left, this is in between -4 and -5. So again, I'm gonna estimate this. I'll say -4.5. I don't know exactly. And there's going to be a different strategy that we can use to find out a more exact answer, but for now, that's our estimation. I do want you to notice that when they reference x-intercepts here, they have in quotations marked that this could also be called solutions. We'll explore that idea a little bit more. There are two x-intercepts. We can see that in the graph. What we can't see is that this also has, on this graph, our x-intercepts are not whole number answers, which is why we couldn't find them by factoring or rational answers. So there's another strategy. It's called the quadratic formula. The quadratic formula can always be used to solve these quadratic equations. It's just not everybody loves it all of the time. So it's a formula, and it can take a couple steps, which is why not everyone likes it. The quadratic formula is really, really easy to use if we have things in standard form. So if we want our equation, our function, our quadratic equation can be used if the function is written in descending order and we want it to equal 0 on one side. And when it's in descending order, the coefficients of the terms are going to be labeled as A, B, and C. And those are numbers. And so what we're going to do is use this formula and replace the variables I'm going to write down in this equation with the numbers that would be in those locations in our quadratic equation. So the formula is x can be found by doing negative b, or the opposite of b, plus or minus, which we'll come back to, the square root of b squared minus 4ac all over 2a. This is one that often people memorize. We are going to give you guys this for your tests, but it's one that comes up enough that it's worth memorizing. There's a little story that I'll tell you that will help you memorize it. There's also a song that I'm not going to sing for you, but if you go to YouTube and you look up the Quadratic Formula song, then you're going to have plenty of opportunities to listen to it that way. All right, but here's the story. A negative boy, B for boy, couldn't decide whether or not to go to a radical party. So a square root symbol can also be called a radical, or stay home and be squared and miss out, that's like our subtraction, miss out on seeing 4 awesome chicks. And the whole party was all over by 2 a.m. I would like to say that at this party, nothing bad happened. It was only good stuff. It was a very innocent and fun party, lest you get bad ideas. If you need to hear that again, you can rewind this. So I'm going to go and use this formula to try to find answers here for these problems. The first one is the one we actually tried factoring earlier, and we couldn't because it was prime. You might notice that this is written in standard form, in descending order, and we've got it set equal to 0. A is going to be the coefficient of the x squared term. B is the coefficient of x, and C is the constant, including its sign. So I don't want to lose this negative that is attached to that 7. What I'm going to do to start this off is I'm going to rewrite this problem. I'm just going to pull from my formula, and wherever it says B, I'm going to put in a 3. Wherever it says A, I'm going to put in the number 1, and wherever it says C, I'm going to replace that with negative 7. So negative B, there has to be a negative in front of that B. Sometimes I'll call it the opposite of B. If B already started off as a negative, I would turn it into a positive. Plus or minus the square root of B squared. Well, B squared is 9. You could write 3 squared if you want. You're going to have to simplify it at some point. Minus 4 times A times C, including that negative, all over. Make sure when you write this fraction bar that it goes over the entire expression, not just the part underneath the square root. All over 2 times A. I know this looks a little intimidating, but we're just going to go ahead and simplify this. It's not near as bad as you might think. First of all, a lot of this can just be recorded down again. Now, simplifying inside the square root, we do have to follow order of operations, which says that we need to do multiplication before we do addition and subtraction. Now, by the way, you could actually type this whole thing into your calculator, because calculators will do order of operations. So you could actually type 9 minus 4 times 1 times negative 7. It'll give you the same answer. But if you don't have a calculator, you can still do this. But keep in mind, this minus is attached to the 4. So I'm going to just keep the 9 here. And a negative times a negative would make this a positive. 4 times 1 times 7 is 28. And then on the denominator, 2 times 1 is 2. I do want to finish this off by doing this addition, and then I'm going to actually be done with this problem. I'll end up with negative 3 plus or minus the square root of 37 over 2. Later on in the year, we might show you guys some that simplify a little bit more than this, but for now, we're going to go ahead and stop right there at that problem. Example 2 is similar. We're starting off in standard form. A is the coefficient of x squared. B is the coefficient of the x term, and C is the constant. So, when I write out the formula, x is equal to, I'll pull this so that you can see the formula up here. Okay, so I'm referencing this quadratic formula. It says negative b. B is 2. I want it to be the opposite sign. So negative 2 plus or minus the square root of b squared, which is 4, minus 4 times a times c, all over 2 times a. There's a lot of 4's in this problem. Sorry about that. So x is equal to -2. Plus or minus, I'm going to need to square root, simplify inside this square root. If you are doing this by hand, you should always do the multiplication before you try to do the addition and subtraction. This would really be 4 minus 16. And then on the denominator, that'd be 8. I'm now going to go ahead and finish the subtraction. Now you could use a calculator to help you inside that square root if you'd like. This one causes a little bit of a problem here because of this. I want you to think back to what we talked about a little bit earlier in the year. A square root means a number times itself to give you that value. That's why the square root of 25 is 5. Because 5 times 5 gives you 25. Well, how can you do a number times itself and get a negative? You actually can't do that with real numbers. You can do it with something called imaginary numbers, which we're not going to worry about this year. You're going to learn about that in the future year. But you cannot, with real numbers, multiply something by itself and get a negative. So if you get a negative inside the square root symbol, you can stop the problem and say, hey, there's no solution. I use that symbol for no solution. Some people write NS. Some people write out inwards, no solution. The next couple problems are for you to try on your own. Please pause the video and try them. And when you're ready, restart and I'll show you the solutions. Here are the solutions for 3 and 4. Please pause the video and look them over. Compare them with what you did and fix any errors that you may have.